Here is our fourth practice problem, Euclidean geometry, grade 10. So this is BHSP is a rhombus whose diagonals intersect at point A. So here we have point A. BA is equal to 8 centimeters. AP is 6 centimeters. The line AC is drawn parallel to BP as shown in the diagram below. So you guys, the first thing that you should start off with here is the fact that this quadrilateral is a rhombus. So let's fill in our properties of a rhombus. We know that opposite sides are, well, firstly, let's fill this in. Opposite sides are parallel. We know that all sides are equal. And one more thing I need you guys to notice is that they told you that this line BP and AC are parallel to each other. Okay, there are a few other properties that we know as well. We can fill them in as we go along, so as we need them. 4.1 says, write down the size of angle BAP. So an important property of a rhombus is that the diagonals bisect each other, but also that they bisect at 90 degrees. So where we need to get angle BAP, that question is just purely testing you on the properties of a rhombus. Angle BAP is 90 degrees. Let's write that down. And our reason is diagonals of a rhombus bisect at 90 degrees. Let's go on to 4.2. We now need to calculate the size of the length of BP. So if we focus on BP, this is the length that we need to calculate. Now I want you guys to notice this triangle. Let's call it BAP. That is a right-angled triangle. So clearly we can use the theorem of Pythagoras. Now BP lies opposite the 90 degrees. So BP is the hypotenuse. Let's start off by writing down the theorem of Pythagoras. So the general rule for Pythagoras is r squared is equal to x squared plus y squared. Now the hypotenuse here is BP, so BP squared. For x and y, you can interchange between those sides. I'll take x as AB and y as AP. Let's now substitute. So BP is what you're solving for. AB is 8. AP is 6. Now you can calculate this separately, add it and then square root, or you can square root both sides immediately, which I actually prefer to do. It saves you a bit of time. So we get BP as 10 centimeters. So here BP is 10 centimeters. Now 4.3, write down the length of AC. I want you guys to focus on this triangle, SPB. So in triangle SPB and including the line AC. And I want you guys to notice that this is your midpoint theorem triangle. Okay? Midpoint theorem triangle. And why is it the midpoint theorem triangle? Remember that the diagonals bisect each other. So these diagonals are all equal to each other. So within this triangle, notice that AC is drawn from the midpoint of one side of the triangle to the midpoint of the other side of the triangle. And it is parallel to the third side. That is purely the midpoint theorem. From the midpoint theorem, what we know is that these two sides that are parallel, they are in a ratio of 1:2. So if this is 10 centimeters, AC has to be 5 centimeters. Now that makes sense why this question is only 2 marks, 1 mark for saying that AC is 5 centimeters and 1 mark for your reason. So I have seen some cases where in some questions when they use the midpoint theorem, instead of writing midpoint theorem as the reason, they write the actual midpoint theorem, where they say something to the effect of a line drawn from one side of the triangle to the midpoint of the other is parallel to the third side. But that in itself is the midpoint theorem. So midpoint theorem is accepted as well, and sometimes you can give the entire theorem as your reason. Okay, so we have AC as 5 centimeters. Now 4.4 says determine the area of quadrilateral BHSP. So BHSP is the entire shape, and we need to get the area of this shape. So you guys, we're going to be smart about how we do this. You do not have a formula for the area of the rhombus. It's not a common thing that you do. But what I need you guys to notice is that we know that the diagonals bisect at 90 degrees. What this now tells us is each of these triangles are right angle triangles. So we've got 1, 2, 3, 4. Maybe it's better if I just say there's 1, 2, 3, 4. We've got 4 right angle triangles, and what do we know about them? They are identical. They're all exactly the same. This is a rhombus. So how can we calculate the area? If we have a right angle triangle, you guys know area of a triangle is half base times height. This is something that you learned in primary school. So let's calculate the area of one triangle. I'm going to focus on this triangle, and all I have to do is multiply that area by 4. So let's mention which triangle we're working with. Let's call it BAP. So I'm going to say area of triangle BAP is going to be half base times height. You can, if you want to label it, give it proper names, you can. Let's take the base as AB and the height as AP. So you guys, here's the thing. If you're not sure which two sides to take as the base and the height, it is always the two sides that create the 90 degrees. So the two sides that have the 90 degrees between them. Now AB is 8 and AC is 6. So let's substitute. This should give you 24 centimeters squared. So remember, for area, your unit is always squared. Now, since we know the area of the one triangle, we're just going to multiply it by 4 to get the area of BHSP. So, area of BHSP is going to be 4 times 24, which should give you 96 centimeters squared. That is your final answer. So we are done with this question.